For this video, we're going to look at how we can handle a two-sample z-test for proportions, as we're going to look at this basic stuff here with 8.4, where in this case, we are looking at studies of cars and pickup trucks, and what we're going to do is go into Stat, Tests, and select option 6, the two-proportion z-test. Where in here we need to be careful of the fact that we are given these proportions p hat 1 and p hat 2, but nicely they've also given us the x1s and x2s here, where just for reference I'm going to pretend that they don't, because in the homework they often don't. And if you want to get that x1 indirectly, what you would do is you put in 0.910, the proportion, and the associated n value, multiply those together, and it will give you the x value, where you want to round that following the standard scheme. And then here we have n1 is just 200, while x2, I'm not going to put the multiplication in there again, is 208, and n2 is 250, where here we are testing at alpha equals 10% about the claim that the proportion is the same. So we're running the two-tailed version here, that is p1 does not equal p2. We're going to calculate that, and what we'll get here is a z-score of about 2.42 and a p-value associated to that of about 1.6%, which is well below alpha equals 10%, but if we wanted to be sure and get our critical values here, we could do something like the inverse normal function here with, depending on how you want to see this, 5% in the left tail or 95 for that right side, since we want 10% and two tails, which will give us one of those traditional z-scores of about 1.645. And whether we reject based on that or we reject based on the p-value, in either case we are rejecting the null, which is to say that we have enough evidence to reject our claim that the proportion is the same. For our second example here, we have that the research team is looking at the effects of cholesterol-reducing medicines, where here we have these same values like before. So we're going to go into Stat, option 6 for our z-test, where here x1 is 301, n1 is 4700, and accordingly p1 is about 6%, while x2 here is 357, and n2 is 4300, where we are running this on the test with alpha equals 1% to conclude that the death rate is lower for those who took the medication than those who took the placebo. And you'd hope that that's lower if this drug has any effectiveness. But we should be careful here again to understand that the choice to make this test left-tailed is just a little bit arbitrary here, based on the fact that I made x1 and n1 associated to the trial rather than the placebo, as it were. But anyway, we're going to have that, and we run it, and we'll get here a z-score of about negative 3.46 and a p-value that is approximately 0.0003. It's a very, very low p-value, which is to say that we would be rejecting the null hypothesis, where if we want to be sure, we want to do this using that critical value method instead just as well. We would use inverse normal, 0.01, and from that we would get our break off at about negative 2.33, where we pick 0.01 because it's a left tail with 1% level of significance alpha. But in any case, we reject the null hypothesis, so we say there's enough evidence to support the claim here because we were claiming that the death rate is lower. In this case, it seems like it's pretty significantly lower, in fact.